Welcome to Knight Optical's in-house metrology lab. Metrology is the science of measurement for optical components. That can be measuring their dimensions to ensure they fit into housings, measuring the surface quality, measuring their coatings, or measuring their focusing abilities. Let me walk you through some of the machines that we use. This is our Zygo Verifier interferometer. It uses a collimated red laser to measure the surface or the transmission through various optics to measure their image quality and how the surfaces can impact that. Currently, a lens is being measured for the irregularity and the power, which will affect where it focuses and the quality of that focal point. This is accurate down to lambda over 20, so approximately 30 nanometers. We're talking the size of a virus at that point. So really precise bit of kit that has a massive impact on the image quality at the end. This is our Prism Master. It's used for measuring the angles on optics, windows, prisms, other types of plane surfaces. It's really important for prisms because it will detect the deviation of the angles. Any surface that's deviated from where it should be will direct your beam differently to how it should. So you will have an imaging system imaging the wrong area. For certain plane optics, if you have an angle between them, they'll actually bend to the light rather than being able to look straight through it. So this can detect any changes there. It's accurate down to a couple of arc seconds. So that's, less than 1,000th of a degree, really tight tolerance. This is our optispheric. It's used for measuring the focal length and the radius of lenses. So that impacts where they focus, ensures that they are correctly in the barrel to give the image at the right position on your sensor. You can also measure the MTF and other quality of image measurements. Currently, we've got our optocentric add-on, which is rotating the lens, allowing us to measure how well centered that lens is, assuring that the lens focuses in the same space, no matter positioning in its housing. Here we have an assortment of different gauges. These are used for precise dimensional measurement, diameters, thicknesses. That allows us to control how well they fit into a housing. The distance from the focal length to the surface is a big importance. So ensuring the thickness is correct is really important. We've got this granite block here, so that's flat to less than 2 wavelengths of light, approximately a micron flat across the whole surface, which ensures accurate measurement across all of our devices on this. This is our Starrett imaging system. So it measures non-contact dimensional measurements. Currently we're measuring a graticule and the spacings between them. This is really useful for a lot of materials where they're delicate. We don't want to be touching them with metallic gauges like we've seen. This can measure non-contact via just contrast edge detection. Resolution is 1/10 of a micron on this. Really precise bit of kit. Yeah, really useful for measuring things where a gauge can't get into or can't touch for whatever reason. Any awkward stuff usually finds its way onto here. You can also program it to automate measurements, which is really useful for large batches of parts. Here we have a couple of Carey 5000 spectrometers. These are used for measuring the transmission through materials and coatings, and then the reflection of coatings can be measured with our universal measurement accessory that's on this one here. We can place an optic in here, and we've got a full 180-degree rotation that can measure specular reflectance at different angles. Often this is used for various types of mirrors, either gold, silver, aluminium, or dichroic filters or beam splitters. We also have a diffuse reflectance array, which can be used to measure the diffuse reflectance or the diffuse transmission of diffusers and other optics. And finally, this is our Carey 660 FTIR spectrometer. This is used for measuring infrared optics such as germanium, silicon, zinc, windows, which can't be measured on more traditional spectrometers such as these. Works via Fourier transform, so a lot quicker than a standard spectrometer, a lot nicer to use as well. Our in-house metrology lab allows us to ensure that everything that we send out conforms exactly to your specifications and does exactly what you require it to.